Hello everyone. In this video we are discussing about the force acting between the two wires, and these two wires are carrying current and kept parallel to each other. So these are the two wires, I1 and I2. Just for notation, I will give this wire number 1 and this wire number 2 so that later on I can refer them. So when this wire is carrying current I1, it will generate magnetic field around itself. By using right hand thumb rule, we can find the direction of magnetic field around this wire. So if you already know how to use right hand thumb rule to find the direction of magnetic field around the current carrying conductor, then you can use that rule, or it's very simple to use. Imagine this is a wire which is carrying current in upward direction. If I hold this wire in my right hand, then the thumb will point in the direction of current and my curled fingers, they are pointing in the direction of magnetic field generated around the wire. To the right side of the wire, magnetic field lines are going backward, and to the left side of wire, magnetic field lines are coming towards you. Or if I keep this pen on this board, then the magnetic field lines are going into the page or the whiteboard, and to the left side of this wire, the magnetic field lines are coming out of the whiteboard or page for you. Now, when magnetic field lines are going into the page or going into the screen or going into the whiteboard, we represent them by a cross. And when magnetic field lines are coming out of the page, we represent them by dot. Because this convention of representing magnetic field is inspired by the arrow. If you see an arrow looks something like this because of its structure. This is the head of the arrow and this is the back part of the arrow, tail of the arrow. If you look the arrow from front side, it means when the arrow is coming towards you, then this head of the arrow looks like a dot. And when the arrow is going away from you or away from us, then the back side of the arrow looks like cross. So when magnetic field line is going into the page, what we are seeing is we are seeing the back side of the magnetic field line. That is what we assume, at least. So these are the field lines which are going into the page, and these are the field lines which are coming out of the page. Now wire 2 is kept close to wire 1. So it means it's going to experience the magnetic field which is generated by wire 1. So now wire 2 is in the magnetic field of wire 1. If you have seen the last video, then you know if there is a charge flowing into the magnetic field, it will experience force. Or if there is current flowing into a wire which is kept in magnetic field, it will experience force. Same thing is going to happen with this wire 2. So as I explained you in the last class, father, mother and child, this notation I had used for force. Mother, magnetic field, C for charge or current, right? So same thing we can apply here. Magnetic field is going into the whiteboard and current is going upward. So the direction of force would be You can see it towards my thumb. So the direction of force should be towards the left side on this wire. So this wire is attracted towards wire 1. Wire 2 is attracted towards wire 1 because it's experiencing a magnetic force. Now, if we take the direction of current in wire 2 and apply same concept here, then we can see that the wire 2 is carrying current upward. It will generate magnetic field around itself. So as you had seen here in this case of I1, we will apply same thing here. Let me clear this board first. If you use the right hand thumb rule, wire 2 is carrying current upward. So magnetic field lines would be something like this. It means magnetic field lines to the right side, they are going into the page. And for me, they are going into the whiteboard. And to the left side of wire, they are coming out of the page. Or they are coming out of the whiteboard. Now, as this wire 1 is kept close to wire 2, then it will be in the magnetic field of wire 2. And more field lines. So magnetic field lines to the left of wire 2, they are coming outward, and in those magnetic field lines, this wire 1 is kept. Now if you apply the same Fleming's left hand rule here to understand the direction of force, you can find the direction of force easily. So let's apply the Fleming's left hand rule. Now the direction of magnetic field is towards the camera or towards you. It means it's coming out of the page. Current is still upward. Current is still upward. So the direction of force experienced by the wire should be towards the right side. So what is direction of force? It's towards the right side. Earlier you had seen that direction of force on wire 2 due to wire 1 was towards left. Now the direction of force on wire 1 due to wire 2 is towards the right side. It means these two wires, they are attracted. So you can say here, when current flows into parallel wire in same direction, they attract. So force between wires is attractive. You can apply same principle when two wires are carrying current in opposite direction, but still they are parallel to each other. You will find that the force will be repulsive in nature. It means they both will repel each other. I will leave that practice to you to check how the force will be experienced by wire 2 and wire 1 in this situation. If you like the video, please hit the like button and subscribe and share with your friends.